Corporation of Greater Mumbai. We'll be doing Pythagoras Theorem today. Now, before that, first let me tell you that Government of Maharashtra Education Department for this year have reduced 25% of the syllabus. Okay, so first we'll have a look at the reduced syllabus for this year. Okay, so you all can mark this in your textbooks if you want, or you all can remove the screenshot. Now see here, chapter number 1, similarity. So if you go to page number 8, your angle bisector theorem from top line 14 to 21 page. Okay. Then page number 9, complete page. Page number 10, you've got converse of angle bisector theorem, property of three parallel lines and their transversal, and theorem based on it, complete page. Page number 11, remember this from top line, it's 9 to 19, example 3 and 4. Page number 12, solved example 2. Activity from top line 10 to 24. Page number 13, activity from top line 1 to 9, and check these questions from practice set 1.2. From practice set 1.2, these questions have been reduced. Question number 1, question number 2, question number 3, 5, 6, 7, 8, 9, and 11. So that means only two questions, that is question number 4 and question number 10. Okay, will be there for evaluation. All these questions will be for self-learning. Now, if you move to problem set 1, that is on page number 28, page number 29. If you move to problem set 1, then you have got question 8 to question number 10. Okay, been reduced. It would be there for self-learning. Okay, so these were the topics from chapter number 1, similarity. Now we'll move to chapter number 2, that is Pythagoras Theorem. Now if you check Pythagoras Theorem, page 40 to 42, complete page. Okay, they have been omitted. The next, if you move to page number 43, you come on page number 43, there is practice set 2.2. Okay, so from practice set 2.2, question number 1 to question number 5, that means complete practice set 2.2 has been omitted. Next, when you come to page number 44, okay, now this is in problem set. Okay. So MCQ question number 6, this is problem 2, problem set 2. Okay, in that MCQ question number 6. And after that, when you come to page 45 to 46, question number 8, 9, 12, 17, and 18, they have been omitted for this year. This was done for last year also. So the same thing, okay, the same portion is for you all this year. Then chapter number 3, circles. Page number 75. Theorem of angle between the tangent and the secant. 76 to 82. Complete page. Page number 83. Problem set 3. Question number 1, 7. Then page number 87, 88, 89, 90. We've got question number 13, 15, 16, 18, 22, and 24. Is this clear? You all can remove the screenshot of this. You can remove the screenshot of this. And you can mark this in your textbook afterwards. We'll move ahead. to the next part. Now, chapter number 4.
आवाज तो आ रहा है
Chapter
अभी
number
क्या
4.
पता
Yes, beta, who is this?
दूसरे टीचर है।
Sanjana, beta, any
टीचर नहीं
problem?
है
Sanjana Chauhan, any problem, beta, from Tilak Nagar? Okay. Now, chapter number 4. Geometric constructions. Now, in this chapter, nothing has been reduced. Okay. So, complete chapter will be there for evaluation. Now, after chapter number 4, we move to chapter number 5, coordinate geometry. Now, in coordinate geometry, page 116, slope of a line, activity 1, from top, line 10 to 26. Self learning. Page number 117 to 121. Complete page. This complete page will be for self learning. Page 122. From top line 1 to 4. Question number 6 to 8. Then you have got problem set 5. Question number 1. In that sub question 4. Question number 2. That's sub question 1 to 3. Then you've got page 123. In this, question number 9, question number 10, question number 22. Next, move to chapter trigonometry. Chapter number 6, trigonometry, page 132 to 137. Page 132 to 137 and word problems based on that. All this, whatever this page is, the content on this page is page 132 to 137. Everything has been omitted. Next, chapter number 7, mensuration. Page number 140 to 163. Complete part. So again, this year you didn't have mensuration for your evaluation. It's completely omitted. All other parts, therefore, self-learning. You have to do it on your own. Is this clear to all the students? You all can remove the screenshot of this so that we'll move ahead. Remove the screenshot of this. Yes, there are a few doubts. We'll solve those doubts first. Yes, Aditya, Diksha.
Hello, good morning, sir.
Yes, good morning, beta.
Sir, that in fifth lesson coordinate geometry, that all
Yes,
the activities and that reduce or we have to do it.
yes, all they have been reduced. Okay, but you have to do on your own. It's for self-learning. Okay, for this you can take help of your teachers.
Sir means syllabus is reduced for the exam.
Yes, yes, yes. That syllabus has been reduced. Whatever I've shown on the screen, everything has been
Okay, thank you,
reduced.
sir.
Yes, beta. Thank you so much. Yes, now we'll move ahead. So all the students have understood whatever syllabus has been reduced. Okay. So now you can plan your studies according to this syllabus. Okay, you all can go ahead with this reduced syllabus. Okay, you all can plan how to study this year because again this year because of corona again the chances of physical classes understand okay will be a bit less. Understand? It will come up only in the cities where the corona patients are very less. So again, we have to move ahead with whatever situations we are facing this year. So in accordance to that, the government decided to reduce the portion. Understand the part omitted from syllabus for year 21-22. See what things you don't have in this chapter. Now we are talking regarding the Pythagoras theorem. So it is application of Pythagoras theorem, and next is the Apollonius theorem. Is this clear to all the students? You all can remove the screenshot of this. We'll move ahead. Now see, in this chapter, the first important thing is Pythagorean triplet. Now, in a triplet of natural numbers, if the square of two largest number is equal to the sum of the square of remaining two numbers, then the triplet is a Pythagorean triplet. For example, it is a Pythagorean triplet is a set of positive numbers, say A, B, and C, that fits the rule A square plus B square equals to C square. For example, 3, 4, 5. So here 3 square is 9, 4 square equals to 16, and 5 square equals to 25. So what did you understand from this? What did you understand from this? What did you understand from this? That the square of the largest number, 3 square, 5 square, okay, equals to 3 square plus 4 square. So 25 equals to 9 plus 16. So yes, it is a Pythagorean triplet. So see, these questions, compulsory questions, they do come in your examinations, and these questions are very simple to solve. Understand? What you have to do here is you have to just understand the basic trick in this. What is the basic trick? Whatever is the greater number, just separate it out. Okay. Whatever is the greater number, understand, just separate it out. And then what you do is you check the other two. You check the other two. Understand? And you try to add their squares. And you try to add their squares. 9, 16. You try to add them. 9 plus 16. Is this equal to the square of the largest number? You have to check. Understand? Check. If the answer comes yes, the answer comes yes, it's a Pythagorean triplet. It's a Pythagorean triplet. Is this clear to all the students? Very simple. The property of 30, 60, 90 triangle. Now this property I've studied last year also. You had theorem based on this. Understand? We just revise this a bit. If acute angles of a right angled triangle are 30 degrees and 60 degrees. Check. Acute angles means the angles which are less than 90 degrees. Understand? So you know in a right angled triangle, the two angles will be acute angle. Then the side opposite to 30-degree angle. Check. This is very important. Side opposite to 30-degree angle is what? Half the hypotenuse. Is what? Half of the hypotenuse. And the side opposite to 60 degree. Okay. Side opposite to 60 degree is what? root 3 upon 2 times. Now times here means multiplied with root 3 upon 2 multiplied with times the hypotenuse. Okay. Now we'll just have a look at the figure here. If you consider triangle ABC in which angle A is equals to 30 degrees and angle C equals to 60 degrees and the angle B which is remaining is 90 degree. Check. Now if you look in this triangle, triangle ABC, which is the side opposite to 30 degrees. Side opposite to 30 degrees BC. Check. What you do is you can here do a simple trick. Wherever you'll get this 30 degrees, just draw a arrow in the downward direction here or towards the side, okay, in front of 30 degrees. That will be your opposite side. That will be your what? Opposite side. Is this clear? That will be your opposite side directly. So side opposite to 30 degrees is what? Half the hypotenuse. Now how to guess out the hypotenuse? We draw a simple arrow from 90 degrees. Okay. Okay, the side opposite to 90. Understand? A straight arrow. So you'll come to know that this is your hypotenuse. So that means your value of BC, value of BC is what? Is half the hypotenuse, that is EC. We'll move ahead. Side opposite to 60 degrees is what? AB. Check now. In order to avoid confusions, I'm using this arrow signs. Understand? So it is AB. So BC equals to half AC and AB equals to what? It's root 3 upon 2 times. Check. Times means multiplication. So root 3 upon 2 AC. Now this will be applied to most of the problems which you're going to solve. So you have to understand this. Side opposite to 30 is half. Side opposite to 60 is root 3 upon 2. Then property of 45, 45, 90-degree triangle. If the acute angles of the right angle triangle are 45 degrees and 45 degrees, then each of the perpendicular sides is 1 upon root 2 times the hypotenuse. Again, the word times means what? Multiplied by 1 upon root 2, understand? Multiplied by the hypotenuse. Is this clear? Now you'll look out at the figure. Check. Now if you consider triangle ABC, angle A equals to 45, angle C equals to 45, and angle B equals to 90. So side opposite to 45 degree is here. Now check. It is an isosceles right angled triangle. See this 45, 45, 90 is a special kind of a right angle triangle, and the name is isosceles right angled triangle. So now in this you're going to get the two sides equal. Understand? Now yes, check. Side opposite to 45 is BC and AB. So I'm showing them with the arrows. So yeah, this is the special kind of triangle as I have already mentioned. And this is what it is called as isosceles right angle triangle. So in this, you'll get AB equals to BC. You're going to get AB equals to BC. So BC equals to AB equals to 1 upon root 2 times. So multiplication. So 1 upon root 2 EC. Is this clear to all the students here? Very important properties which will be applying. Similarity and right angle triangle. Now this is very important property. In a right angle triangle, if the altitude is drawn to the hypotenuse, then the two triangles formed are similar to the original triangle and to each other. Understand the statement. What is the statement? In a right angle triangle, in a right angle triangle, if the altitude is drawn to the hypotenuse, then the two triangles formed are similar to the original triangle and to each other. So first we have to look at the figure here. Check. ABC is a right angle triangle. Understand? And BD is the altitude which is formed or which is drawn. Understand? BD is the altitude which is drawn. Then the two triangles formed. Okay. Now check when you are drawing this altitude. Understand? When you are drawing this altitude, what has happened? The original triangle now is divided into two parts. So these two triangles, understand, they are similar to the original triangle. So the two triangles which are formed, that is triangle ADB and triangle CDB. Check these two triangles. These two triangles which are formed, understand, they are what? They are similar to the original triangle. Your original triangle is ABC, the bigger triangle ABC. And these two triangles, triangle 1 and triangle 2, they will be similar to each other. Understand? Now we'll move toward the proof of this. So which things are given to us? We'll first make a note of this. So from the given statement, check, you'll be given a right angle triangle and you'll be given a altitude. So check in triangle ABC, go with the words. In triangle ABC, angle ABC equals to 90 degrees. BD is perpendicular hypotenuse AC and A dash G dash C. Understand? Check. BD is the altitude and point D, it lies between A and C. These things are given to us. Check. Whatever comes after if or whatever comes before then is given, and whatever will follow after then will be to prove. So what you have to prove? You have to prove that triangle ADB is similar to triangle ABC, means to the original triangle. Triangle BDC is similar to triangle ABC, that is the original triangle. And triangle ADB is similar to triangle BDC. Listen, these things you have to prove. Now check. For similarity of triangles, how many tests are there? There are three tests. So out of that, okay, which test will be applicable or which test is used on a larger scale? That is the angle test. So we'll keep our focus mainly on angle test to prove these two triangles similar to each other. Getting this? So now we'll begin with the proof. In triangle ADB and triangle ABC, and when you are considering these two triangles, check ADB and triangle ABC. Now both are right angle triangles because you know when you draw the altitude, it is going to make an angle of 90 degrees. Check here, 90, 90. So first pair of angle you will get directly here. Now the other pair, check ADB, ADB is here, and then you've got ABC. Understand? Now when you have a closer look at these two triangles, you'll get to know that angle A which is there, check angle A which is there, okay, is going to come common. Is going to come what? Common for both these triangles. We've got one angle as 90. Understand? We've got one angle as what? 90 degrees. And you've got the other angle as, check, you've got one angle as 90 degrees and other angle is what? Common. So angle and angle. So by angle test, you can show that these two triangles, they are similar. Check angle DAB equals to angle BAC, common angle. Angle ADB equals to angle ABC, each 90 degrees. So therefore, triangle ADB is similar to triangle ABC by angle test. This is just statement number 1. We'll move ahead. In triangle BDC and triangle ABC. Again, triangle BDC and triangle ABC. Angle BCD equals to angle ACB. Again, same thing. If you have a closer look, they will be common angle. These two triangles now, BCD and ABC. This angle C, which is the angle C, okay, is common. Is what? Common angle. And the other pair, you know this pair, 90. This pair, 90. So again, one angle is common angle, the other is right angle. Got the man with the plan right here. He's right with the man right here. Live it up once. So therefore, you'll get triangle BDC is similar to triangle ABC by angle test. Is this clear? So therefore, triangle ADB is similar to triangle ABC. Now, from where did we get this? From where did we get this? Can anybody tell us? This property is transitivity property. Understand? Check. ADB similar to triangle BDC, similar to triangle ABC. Transitivity. Is this clear to all the students? Very simple question. Sorry, very simple theorem instead of question. It's very simple theorem. Now, next important theorem is the Pythagoras theorem. Now, what is Pythagoras theorem? Well, this also you're studying this from 5th, 6th standard, the statements. Understand? In a right angled triangle, the square of the hypotenuse is equal to the sum of the squares of the remaining two sides. Is this clear? Is this clear? Any difficulty, students, in getting this? You all can let me know. Just a minute. consider right angle triangle ABC. Just a minute. Yes, ma'am. Consider triangle ABC. Check. What is given? Angle B is equals to 90 degrees. Let AB equals to P, BC equals to B, and AC equals to H. To prove H square equals to P square plus B square. Construction. Draw a perpendicular BD from B to AC such that AD is equals to X and value of CB equals to H minus X. Proof. Consider the two triangles, triangle ABC and triangle ABD. Now what you'll get in this? These two triangles are similar to each other because of angle test of similarity. Hello. Just a minute, students. Hello. Hello. Yeah, so now consider two triangles, triangle ABC and triangle ABD. These two triangles are similar to each other because of angle test of similarity. So both the triangles have a right angle and one common angle at vertex A. Understand? So students, now you all can guess out. You all can guess out which it is. You all can guess out which the triangles are. Come on, tell me. Come on, students, guess it out. Yes, Karan, can you tell me? Karan had raised his hand. Okay, he's put his hand down again. No worries. No. Triangle ABC and triangle BDC both are similar. Both these triangles are what? Similar. Yes, Imtiaz Ansari.
Yeah, I'm sorry.
Yes, beta. What is your problem, Imtiaz? Can I ask?
Sir, ABD and BCD is a similar.
Yes, ABD and
BCD is similar.
BCD is
Similar.
similar. Yes, both are what? They are
Similar.
similar. Yes, very good, beta. Very good.
Thank you, sir. So unmute करूँ?
Yes, you can unmute, beta. Yes.
Okay.
So now, with help of this, now as these two triangles, they are similar. As these two triangles, they are what? Similar. What you are going to get? You are going to get P upon H equals to X upon P and B upon H equals to H minus X upon B. Now, as you know, corresponding sides of similar triangles is the reason behind this. So P square equals to H into X. That is statement number 1. But you'll get P square equals to H into X. B square equals to H into H minus X. You know, both these ratios, okay, you're going to rearrange. Check these two ratios. What you're going to do? You're going to rearrange these two ratios. Understand? So what happens? P into P and X into H. Understand? So P into P becomes P square and H into X. Then you've got B into B, B square. Then H into H minus X. It is H into H. It is H square minus H into X is HX. So you'll get that as H square minus HX. So adding equations 1 and 2. So when you add equations 1 and 2, what you're going to get? P square plus B square. Understand? P square plus B square equals to HX plus H square minus HX. Check this, H into X is HX. Is this clear? So this HX plus H square minus HX. So what happens? Plus HX and minus HX is going to get cancelled off. So it will be remained. The remaining terms will be H square equals to P square plus B square. Now here assumed H to be the hypotenuse. And assumed H to be the hypotenuse, P and B to be the other two sides. Understand? So you've got H square equals to P square plus B square. Understand? Very simple theorem, Pythagoras theorem. This theorem is also asked in your examinations in question 3B. Understand? Compulsory question. It's not compulsory, but in question number 3B, you get at least one question, which is the theorem question. Understand? So you can remove the screenshot of this if you want, so that we can move ahead. Converse of Pythagoras theorem. In a triangle, if the square of one side is equal to the sum of the squares of the remaining two sides. Then the triangle is a right angled triangle. Check. So we'll take a triangle. Okay. And in that you're going to consider AC square equals to EB square plus BC square. But to prove that angle ABC is 90 degrees. Understand? To prove angle B is 90 degrees. Construction: draw triangle PQR right angled at Q such that PQ equals to AB and QR equals to BC. Understand? Check. You're going to draw triangle PQR. Okay. Right angled at Q. Okay. Such that PQ equals to AB. If you look in this figure, check. PQ, okay, is equals to AB and QR is going to be equal to BC. Understood? Now in triangle PQR, angle Q equals to 90 degrees. So as that is equals to 90 degrees. Understand? What you're going to get, PR square equals to PQ square plus QR square. This is by Pythagoras theorem. So PR square equals to AB square plus BC square. This is by construction. So from 1 and 2, now if you consider statements 1 and 2, AC equals to PR, therefore triangle ABC is similar to triangle PQR by side test. Therefore, angle P equals to angle Q, that is equals to 90 degrees. As you cannot prove it directly, understand students, you cannot prove this theorem directly. So what you're doing is you're considering, you're constructing the copy of triangle ABC. Is this clear? You all can remove the screenshot of this. Next theorem is the theorem of geometric mean. In a right angled triangle, the perpendicular segment to the hypotenuse from the opposite vertex is the geometric mean of the segments into which the hypotenuse is divided. Given in triangle PQR, angle PQR equals to 90 degrees, segment QS perpendicular to hypotenuse PR, and you have got P dash S dash R. To prove QS square equals to PS into SR. Proof: in triangle PQR, segment QS is perpendicular to hypotenuse PR. So triangle QSR similar to triangle PSQ. This is the property of similarity of the right angled triangles. Understand? You know the altitude drawn. Understand? Divide the triangle into two triangles, and those two triangles are similar to the original triangle and also to each other. Understand? So that property we have applied here, the first theorem which we studied today. Understand the similarity of right angled triangles. So now as these two triangles are similar, their corresponding sides would be in proportion. The corresponding sides would be in proportion. So what you'll get, QS upon PS equals to SR upon SQ. So rearranging the terms, understand, rearranging the terms, check this would be cross multiplied. Then SQ would be multiplied with QS. So both are same, QS and SQ both are same. So QS into QS becomes QS square equals to PS is going to be multiplied with SR. So you'll get that as PS into SR. Very simple theorem. Therefore, QS is the geometric mean of segment PS and SR. Okay. Now this were the theorems in this chapter which we have to study. Now we'll move to practice set 2.1. Identify with reason which of the following are the Pythagorean triplet. Understand the first property which we studied to Pythagorean triplet. The first set of numbers are 3, 5, 4. So now what you're going to do is you'll first remove the square of all these numbers. Understand? Then triplet 3, 5, 4. Remove square of all these 3 square, 5 square, and 4 square. Out of that, just remove the largest number out. Okay, remove the largest number out. Okay. And you'll consider the values of the remaining two numbers. You're going to consider the values of the remaining two numbers. The square of the largest number is equal to the sum of the squares of the other two numbers. If you consider this, therefore 3, 5, 4 is a Pythagorean triplet. Now next set of numbers 4, 9, 12. Understand, 4, 9 and 12. Now out of this again, we'll remove square of 4, that is 16, square of 9, 81, and square of 12, 144. Now check which is the largest square here. Largest square, understand, it's 144. Just remove it out and check the sum of the remaining two. 16 plus 81. 16 plus 81 is equals to 97, but that is not equal to 144. Understand, it is not equal to 144. So as it is not equal to 144, understand, this is not a Pythagorean triplet. This is clear to all the students here. Next is 5, 12, 13. In the triplet 5, 12, 13, again the same thing you are going to do. Remove square of 5, you'll remove square of 12, you'll remove square of 13. Understand? So square of 13, you'll just remove it out, keep it aside, add the remaining two. 25 plus 144. 25 plus 144. So that is equals to what? 169, which is square of 13. So 5, 12, and 13. Understand? They form Pythagorean triplet. They form Pythagorean triplet. Next set of numbers 24, 70, and 74. In triplet 24, 70, and 74. Again, you're going to remove square of all these numbers. 24, the square of 70, square of 74. Remove square of 74 aside for some time. Add square of 24 and square of 70. So 576 plus 4900 is 5476. Now 5476 is square of 74. Understand? Check. So because of this, you'll come to know that the square of the largest number is equal to the sum of the squares of the other two. Therefore, 24, 70, and 74 is a Pythagorean triplet. Next set of numbers 10, 24, 27. In the triplet 10, 24, and 27, 10 square equals to 100, 24 square equals to 576, and 27 square equals to 729. Understand? So you'll remove square of 27 out for some time. You will add the remaining two, that is 100 plus 576. 100 plus 576 is what? 676. Is that equal to 729? No, it's not equal. So because of this, what happens? 10, 24, and 27, they are not the Pythagorean triplet. They are not the Pythagorean triplet. Next is question number 6. 11, 60, and 61. In triplet 11, 60, and 61. 11 square 121. 60 square is 3600, and 61 square is 3721. So you will add this to 121 plus 3600. So that is 3721. Understand? So therefore 11, 60, and 61, they are the Pythagorean triplet. Understand? It is what the Pythagorean triplet. Is this clear to all the students? Your very simple question. Understand? Any difficulty, students? You all can let me know. Any difficulty, students? Come on, you all can raise your hands and ask your difficulties to me. Yes, Rehan and Mehrunisa.
Hello, sir. Good morning.
Yes, good morning, beta.
Sir, can you explain me the properties of Pythagoras theorem?
Okay, I'll explain, but I'll explain the theorem, Pythagoras theorem.
Okay, sir.
Yes, Rehan, what is your doubt, beta? Mehrunisa was the other this child, and Rehan. Okay, now we'll just revise the Pythagoras theorem. So it's very simple. In a right angle triangle, the square of the hypotenuse is equal to the sum of the squares of the remaining two sides. Check, this is your triangle given, triangle ABC. Okay. Now here you consider angle B to be 90 degrees. AB equals to P, BC equals to B, and EC equals to H. We are assuming this. See, I've done this because I want to ease the way we are going to prove this theorem. Understand? So because of this, I've assumed the sides, okay, with some particular alphabets. Now you prove h square equals to p square plus b square. So construction. You draw perpendicular BD from B to AC such that AD is equals to x and CB equals to h minus x. You've drawn this perpendicular. Perpendicular here means the altitude, basically. Understand? if you're going to consider this complete hypotenuse as h, and you have assumed AD to be x. So what would be this remaining side CD? What would be the remaining side? CD. Your CD will be h minus x. Is this clear? Here it's not B, it's CD. It's CD. So consider two triangles ABC and triangle ABD. If you consider two triangles ABD and triangle ABC, now the property of the similarity of right angle triangles, but the property of similarity of the right angle triangles, you're going to get triangle ABD which is formed similar to the original triangle ABC. You understand? That is what I was asking you. So these two triangles, they are similar to each other because of angle-angle test of similarity. Both the triangles have a right angle and one common angle at vertex A. These are the reasons for that. Therefore, triangle ABC and triangle BDC both are similar. So therefore, P upon H equals to X upon P. Understand? You'll get these ratios, corresponding ratios. P upon H equals to X upon P, and B upon H equals to H minus X upon B. So now with respect to this, P square equals to H into X, and B square equals to H into H minus X, opening up the brackets, H square minus HX. So adding equations 1 and 2, we'll get P square plus B square equals to HX plus H square minus HX. Understand? So plus HX and minus HX gets cancelled off. You're left out with H square equals to B square plus P square. What you have to prove. Is this clear, beta? Any difficulty in getting this? You all can let me know. Ma'am, should we wind up the lecture? Yeah?
Yes, sir. Thank you so much, sir.
Yes. Thank you, ma'am. Thank you.